Okay, I'm recording again. I got briefly interrupted. And so the last I was speaking, I said I had generated a principal components analysis and gone into R Markdown in the R Commander option, and then selected Generate Report. And what it does is it pops up in whatever your default browser is, web browser, the full report pops up, okay? And so that's a little bit clunky, but you can save it and take pieces of it to use in your reporting of your analysis. So the first thing you see in this report is the code for the analysis. So you could use that, put it into RStudio and play with it. Here are component loadings. And so the component loadings are useful in a principal components analysis because you can see how the measurements are weighting onto the components. So principal component 1, and we saw from the graph we looked at in the last video, which is this graph, explains most of the variation in the data. And so if I know that, I can look at these loadings, and the loadings range from 0 to +1 and 0 to -1. And we can look at these loadings and see what's influencing this principal component the most. And so it's going to be the factors or the variables that are closer to either positive or -1. And in this case, on principal component 1, I'm just going to look for the first two, the numbers closest to either -1 or 1. 0.53, low frequency, so the low pitch of the sound is loading heavily onto principal component 1, as is the center frequency. So the point at which the frequency, the energy in the frequencies is even. So that's what's sort of explaining, at least drawing onto the right side of the graph or the right side of the principal component. It's shaping out to be center frequency and low frequency. Looking at principal component 2, I'm just looking for the highest numbers again. -0.61 is our high frequency, and that's a high number, as is -0.5, which is the change in frequency. So the four of the frequency variables that we collected, so pitch variables, are explaining a lot of the variation in the ordination. If I were to go on and then look at the third principal component, I can immediately see one that's loading pretty high, and that's the number of notes per second. So the speed of the song is also something that's explaining a lot of the variation in the data. So you can report your loadings for whatever number of components that you use, say, in a graph. And so often it's the first two. If you do a three-dimensional plot, you might explain the third. Or if the third principal component explains quite a lot of variation in the data. Sometimes you have three principal components that explain a similar amount, but their total is something close to 90%, for example. And then you also tend to report your component variances. And so actually, I'll go to the summary statistics of that. But if you look at these component variances, you'll see that you have component 1 being 3, component 2 being 2.1, and component 3 being 1.2. And that's exactly what's plotted here in this plot. And then we will look at the proportion of variance explained, both the cumulative and the individual. And so you can say something about how much of the information in the data set's being explained, say, by the first principal component, which again took that large set of measurements, reduced it down to one axis, one coordinate system. And that first principal component explains about 38% of the variation in the data set. The second principal component explains about 28%. And so cumulatively, which is also reported down here, those two explain about 65% of the variation in the data set. So that's quite a lot. And then if you go up to principal component 3, 15%, you're up to about 70 or about 80% of the variation in the data set being explained by the first 3 principal components. Okay, so let's graph this. This is one of my favorite things about these ordination methods, is graphing the data to see if there's any pattern in all these measurements that I collected. I'm going to go back to our commander, and I'm going to select graphs. And I'm first going to select scatter plot. and just plot principal component 1 as the X, and principal component 2 as the Y. And I'm going to plot by groups. So if we go back to that original map and see, Kanto, we were curious about whether or not the songs differed between Peninsular Malaysia and Borneo. So I'm going to select region because that's the column of data where we can find that information. I'm selecting OK. Then I can go look at my options. And so you can actually draw lines. You can do a least squares line for your plot. And you can see how those lines sort of fit a data set. You can actually do concentration ellipses, so you can draw circles around the points to look to see if the circles overlap or if they differentiate at all. And here we have concentration levels of 0.5 and 0.9, so think of that as 50% confidence and 90% confidence. I think that would be interesting to look at both. And I'm going to select, okay, so generally you don't do both lines and ellipsoids, but I'm going to do that in this tutorial just so that you can see what they look like. I would suggest picking one or the other. I'm going to select OK, and then I'm going to need to share the graph that gets generated. So here is the graph that's generated. Slide it over a little bit. Large, make it not that large, make it a little bit larger. And so we can see it has a nice pattern here. It looks to have the lines look different. The Borneo line and the Peninsular Malaysia line look different. And actually, if I look at this line for Peninsular Malaysia, it doesn't look like, at least along principal component, plotting principal component 1 and 2, it looks like a fairly flat line. But the ellipses also are differentiating. So as groups in two-dimensional space, these do appear to be different. I'm going to now generate a three-dimensional graph just so you can see how cool they look when you use the code in R. I'm going to use R Commander to do this. And so I'm going to stop this share and go back to R Commander. And I'm going to select graphs, 3D graph, 3D scatter plot. And this time you need to select two X variables. So I hold down my Shift key and select 1 and 2. And then I select PC3 for my Y variable. I'm going to plot by region again. And then I'm going to produce 50% confidence concentration ellipsoids around the data set. I'm going to select OK. And I'm going to make sure I'm sharing that graph. And this is what it looks like. So it's pretty cool looking. So it's fun to generate interesting graphics in R. So those are some of the graphs you can generate. Now I'm going to escape out of this and go back to R Commander and just show you some basic hypothesis testing analyses you can do. So using R Commander, you can basically do analysis of variance. And I'm actually going to just do an analysis of variance on the second principal component. You should do it on both principal components. Actually, I'll do it on both. Here's an analysis of variance by region on principal component 1. And I'm going to select OK. And I'm going to actually also do it on principal component 2. And then we will look at the output. And I'm going to generate a report. So I'm going to share the data from my new report. Excuse the lawn mowing sounds. And so the cool thing is every time you add an analysis when you're in R Commander, you get this complete report. So this is the principal components analysis we did a while ago. This is the code for doing the scatter plot. Okay. These are the libraries and the codes for doing the 3D scatter plot. And then at the bottom, we have the code for doing our analysis of variance on principal component 1 and on principal component 2. And so there's the code and also the output. So for principal component 1, we're seeing that is not a significant difference between Borneo and Peninsular Malaysia, but there is a principal component too. And so that's something to interpret. Another option would be to actually do a MANOVA, a multiple analysis of variance, which is a type of analysis of variance in which you're actually comparing two lines. So two data in XY space, two data sets in XY space to see if they're different, if either the slopes of the lines are different, or if the lines are ordinating differently, or any sort of patterns in the data that would look like something like two scatter plots. So you could do that as well. It's not something you can do in R Commander, you'd have to code for it. But this is how far you can get in R Commander, which it allows you to see how you can apply principal components, generate this sort of complex data set, and then do some pretty simple hypothesis testing on it. All right.